So this is what we call active element. So there is another thing called passive element. So let me write that down as well. So as the name suggests, we can assume something. So in active element, we saw that an active element is something that provides electrical energy to the circuit. Unlike the active element, a passive element is one which receives electrical energy, then either converts it into heat or stores it in an electrical field or magnetic field. So let me write this down as well. A passive element is one which receives electrical energy and then converts it into heat or stores in an electric field or magnetic field. So this magnetic field is also sometimes called as inductance. So we haven't seen this term yet, but we will talk about this in great details in our later videos. So then there is an important notion that is called a node. You might have some idea about this one if you had physics in your 11th and 12th class. By definition, we can say a node of a network is an equipotential surface at which two or more circuit elements are joined. So in easy words, we can say a node, you can say it's a surface, it's an equipotential surface at which two or more circuit elements are joined. So there are two terms. So node is related to two terms. So there is one thing called the equipotential surface, right? And then we have a thing called two or more circuit elements. So these are the two things we need to remember. So when we talk about nodes, we need to remember these two things: equipotential surface and two or more circuit elements. So by definition, we can say node is an equipotential surface where two or more circuit elements are joined together. So I'm not going to write this down, not going to write the definition. I think you will be able to do that on your own, but you need to remember this one. So you might be asking yourself, what is this circuit? What are these circuit elements? These are nothing but resistors, inductors. Um, it could be a voltage source or something like that. We will talk about this one also in great details in our later um, lectures. Then there is a thing called loop. As the name suggests, it's an easy one compared to the other definitions. A loop is any closed path of network. It's a closed path of network. So yeah, we have talked about node, we have talked about loops. There is another thing called branch. So some students get confused about this too. So they think loop and branch are the same thing. No, that's not the case. They are different. A branch is that part of a network which lies between two junction points. So I think for the time being, I think it's better not to talk about branches. We will talk about branch and some other thing on our later videos, but for the time being these things are needed: active element, passive element, node, loop. And then we will move into a thing called mesh. There is a thing called mesh. So what is a mesh? A mesh is the most elementary form of a loop and cannot be further divided into other loops. Is that understood? Let me write this down, then I will give some examples that will clarify this one. A mesh is the most elementary form of a loop and cannot be further divided into other loops. Yeah. So till now we have talked about these 5 definitions: 1, 2, 3, 4, and 5. I think it's better for us to get into some real life problems. We will try to solve a problem on mesh analysis, and if time permits we will move into some other topics, but for today we will mostly emphasize on this topic, mesh. So if these things are not needed, I will rub this down. I will wipe this for the time being, and let me get into this portion, this mesh. I will show a problem, solved example, and then if time permits I will give you one problem that you are supposed to solve at home, and you need to let me know the answer of that one. Okay then. So let's say we have a circuit like this. Okay, so this is the circuit that is being given, and we are being asked to find out the mesh currents of this circuit. Okay, the answer is not the answer, the question is we need to find out the mesh current of this given circuit. The first and foremost thing we need to figure out is how many meshes are there. So from the circuit it is evident that we have two meshes, right? This one, this is the first mesh that we have, and this is the second mesh that we have. So if you are having difficulty in understanding a mesh, I would recommend you to have an idea about the loops. So how many loops are there in this circuit? So here is one loop, this loop, right? So let me clarify this one a little bit. Let's say we have a point A here, we have B, this point is D, and this point is C. So that makes it more simple. So in this case we have two loops or two meshes. This is mesh number 1 and this is our mesh number 2. So let me write this down. This is mesh 1 and this is mesh 2. So these are the two meshes we have. So the next step is to mark the direction of this, mark the current direction of these two meshes. The first and foremost thing that you need to remember is the current direction of all the meshes should be in the clockwise direction. So let me draw this down. So the current direction should be like this one, and let me denote this current as I1, and current direction of mesh 2 should be like this, and the in the clockwise direction, and current should be denoted with I2 because we are talking about mesh 2, that's why we have written down I2. We're talking about mesh 1, that's why I have denoted this one as I1. So once we have denoted this mesh currents and written down the mesh current, the next step is to solve this problem using Kirchhoff's voltage law, KVL. This is the second step that we need to perform. But for doing that, do you remember what were the steps involved in solving this KVL problem? If you don't remember that one, let me give you some hint about that. While solving for mesh 1, let me write this down first and then I will explain. For mesh 1, the KVL equation, using KVL equation, we can write down the equation for mesh 1 should be I1 R1 minus into I1 minus I2 into R2. Then we have plus E1 is equal to 0. So you might be having some problem understanding this mesh equation. So let me explain this one further. I have written down I minus I1 R1 here just because in conventional manner we know that if a current passes through a resistor, there must be a voltage drop or potential drop, right? There must be a potential drop or voltage drop across the resistor. This is a conventional rule. So as the current is flowing in this direction, it is going through this resistor, so there would be a potential drop. If there is a potential drop, we denote it with a minus sign. So there is a minus for that case. Then you might be asking yourself, we are talking about potential or voltage, then why we are writing down I1 and R1? Because it's coming from the simple formula V is equal to IR, right? Voltage or potential is equal to current multiplied by the resistance. So as we have denoted the mesh current as I1 and this resistor is R1, so we can easily write, instead of writing minus V here, we can easily write down minus I1 R1. So same goes for this one as well. But while passing through this resistor, two currents are flowing. The first current is I1, the second current is I2. So if you observe carefully, you can see this I1 current is flowing in the clockwise direction, this I2 current is flowing in the counterclockwise direction, right? So what will happen? So let's say if two people are trying to this is not a good example. Let me solve this using this example itself. So let's say if one current is flowing in the clockwise direction like this, another current is flowing like in opposite direction. Let's say it has an amplitude of 5. Let's say we are just assuming, right? It has an amplitude of 5. Amplitude of this current is 5 units and amplitude of this I2 current is 3 units. We are just assuming some numbers. So if 5 is coming in the clockwise direction, 3 is going in the opposite direction, so the resultant current that will be flowing through this resistor is 2, right? 2 ampere. If we have 5 amperes, if we have 3 amperes, so as they are in the opposite direction, so the resultant current will be the subtraction between the two. Right? The resultant current should be this much, and then we need to write down the resistor value. So the same thing we have done over here. So let me remove this. So there is a minus sign because there is a potential drop across this resistor, that's why we have written down this minus sign. Then we have this resultant current I1 minus I2, because I have already explained that one current is flowing in the clockwise direction, another is going in the counterclockwise direction, so both the currents are opposing each other. So this is the resultant current that is flowing through this resistor multiplied by the resistor value, that is I2. So when you multiply current with the resistor, you'll get the potential or the voltage, whatever you call it. Then you might be asking yourself, why is this E1 and why there is a plus sign, why not minus? Because I told you time and again, I have told you before as well, if there is a potential drop, the sign should be minus. If there is a rise in potential, there should be a plus sign. So as you can see, current is flowing like this. So it is going in the clockwise direction. When it passes through this one, so as you can see, the current is actually flowing from this minus to plus, so it's rising, right? From lower potential it's going to a higher potential. It's rising, it's not reducing, it's rising. So rise in potential is denoted with a plus sign. That's why we have written a plus over here. Then the potential itself, E1, right? So in this manner we can write it down. Then we can further simplify this one by writing as E1 is equal to minus I1 R1 plus I1 minus I2 into R2. So this is the equation for our mesh 1. So let me talk about mesh 2. Right. So I think by now you should have some idea about this mesh 2. If not, I will talk about this as well. So let me write this down first and then I will explain. Can we write, if we start from this point, B point, so I have already told you that there is a potential drop across all the resistors. So there will be a potential drop across this R3 resistor as well. So what should be the KVL equation for this one? Can we write minus I2 R3? Then current is flowing from plus to minus. So there is a drop in potential. Drop in potential is denoted with a minus sign. Then we have E2. Then it passes through this R2 resistor, right? So again we have the same old story. I2 current is flowing in this direction, right? I1 current is flowing in another direction, right? So in this case, can we write I2 minus I1 into R2 is equal to 0? Yes, we can write, because this current will flow through this, but there is an opposing current that is coming through this one, that is I1. So the resultant current should be I2 minus I1. So you might be asking yourself, why not I1 minus I2? Why I2 minus I1? It's because we are inside this mesh 2. We are not inside mesh 1. So as we are solving this problem for mesh 2, we need to think from this direction. We need to talk about this I2 current first, then we will look into something else. So the resultant current should be I2 minus I1, and there is a minus sign because I told you time and again that if current flows through resistor, there should be a drop in potential, and the drop in potential is also always denoted with a minus sign. So that's why we have denoted this one with a minus into I2 minus I1. It's multiplied with R2. So that's what we have done, and further simplifications can also be done for this circuit as well. We can write it down as I1 R2 plus R2 plus R3 into I2 is equal to minus E2. So this simplification can be done, and after doing some further simplifications, we can find out the values of our voltages, not voltages, sorry. After further simplifications, we can find out the values of our mesh current. So this is one way of solving it. In exam, you will be given with these values as well. E1 and E2 should be in some numeric values. This resistor value should also be given. So what you need to do is you just need to find out this I1 and I2 values. So this is how we can solve a mesh analysis problem. We have talked about the basics. In later videos, we will talk about how to solve mesh analysis in great details. And for the time being, I will suggest you to have a look at this video once again. If you have some queries or doubts, you can ask me. I will post some problems for you to solve, and let me know your answers by tomorrow. See you in the next lecture.